everyone, I'm Virginia, one of our campus organizers. Today talk about the surface preparation, key role in the specification process. The last minute of presentation will be the question and answer part. Please write your question in the chat box. It's now my pleasure to present Carlo del Rosso, owner del Rosso Vernici, and Angelo Susani, area sales manager Jotun, Italia. Thank you so much and have a good webinar. Carlo?
Hello everybody, and nice to meet you again in Valve Campus. Thank you, Virginia, for the opportunity to be here with you. I'm Carlo Del Rosso, owner and technical director of Del Rosso Vernici and dealer Jotun. Today, I want to introduce a key topic that must precede the application of each paint system. In the last 200 years, the corrosion is studied in a scientific way, but the cost of the corrosion control is in the world is still estimated in billions of euros in the world. Painting and coating technicians and institutes of corrosion control are developing a number of coating systems and to prevent the corrosion for different ambients. All their effort can forward if the surface preparation is not done correctly. Statistically, 80% of the coating failure is caused by an incorrect or inadequate surface preparation. It's for that today, with Angelo Susani, area manager and manager Jotun and NACE third level, we want to pay attention of the surface preparation.
Hello everyone, my name is Angelo Susani. I am area sales manager for Jotun Italy. I am responsible for the northwest part of the Italy. And today I give you some information regarding the surface preparation and the preparation of the steel. For virtually every coating process, the first step, the initial surface cleaning and preparation, is the key step to success of the coating system. Most paint failures are caused by poor surface preparation, poor paint application. No matter how good the paint is, it will not perform on a poorly prepared surface or if poorly applied. Steel preparation prior to cleaning involves the following activity. Steel preparation is the first and most important step prior to surface preparation, since modern coating requires both and clean and rugged surface if they are to have a long-term stability. The only exception is if they are specifically designed for application to poor surface, as for example, surface tolerant. For example, something to consider is the design of the item or structure to be coated. Many structures are not designed with the coating process in mind. Design, defect, and fabrication fault can easily complicate surface preparation and application of a successful coating. This is a typical problem engendered by the work of engineer and designer. We cannot blame the paint contractor for it. Some common design defects that affect the coating process include hard to reach or inaccessible area, rivets, bolts, or idle connection, weld, gaps, overlapping surface, dissimilar metal, sharp edge, and particularly on corner or rug plate. All these defects should be corrected in accordance with the specification and prior to the surface preparation. ISO 12944 mentioned in this slide give us some recommendations and some guidance to the preparation guide of welds, edge, and other area with the surface imperfection. Pre-surface condition, visual inspection should be conducted on all steel items prior to surface preparation. Many factors in surface preparation affect the life of a coating, including residue of oil and grease, and can prevent adhesion or mechanical bonding on the coating of the substrate. Other potential problem related to the condition of the surface are residue of not visible chemical salt that can induce corrosion after the coating. Rust on the surface is another problem. Another could be mild scale, both loose or tight, can cause early or later coating failure. Another problem is related to the sharp ridge, burst edge, or cuts from mechanical cleaning equipment can prevent adequate DFT. This will determine the level of the preparation requirements, such as grinding, filling. Grinding of the sharp edge. A typical structure may contain edges that are many linear feet long, most of which have no rounded edge. For aggressive environment, it is mandatory to round a sharp edge, since paint will not able to give adequate film thickness over it. So, round of sharp edge. Coating generally tend to shrink and pull back from edge, leaving a thin thickness of protective coating. Stripe coating is strongly recommended when you have to protect a sharp edge or a burst, since they need they give a adding thickness to coating that guarantee a long-term corrosion protection. Here we have a picture of a piece of steel blasted at the gray cleanness of SNR 2.5. And you can see in the picture the sharp edge has been rounded and pure to blasting. I must emphasize this point. There aren't coating able to protect the sharp edge. So the steel preparation is strongly recommended. This preparation of welding is very important too. Weld generally present rough, discontinuous area on a plane surface and may have many sharp edges. Too frequently, welds are not cleaned properly, leaving weld spatter, slag, and acid flux. If these imperfections are not removed, corrosion may be encouraged. Weld spatter is generally removed by scraper or disc grinder. However, is not always advisable without consulting a structural engineer. Coating failure will occur if weld spatter is not removed. Further, welds are often tested for crack with chemical test solution, dye penetrant solution, that leave contamination on the surface. Coating applied over this type of surface will not bond well, and coating failure with subsequent corrosion is likely to occur. It is important to remove all trace of this solution. We have a picture of bad welding and no removal of spatters. Weld spatters are particles of molten metal from welding on the surface adjacent to the weld. Weld spatter removed easily with an impact tool such as chipping hammers, but general removal requires grinding with a disc or angle grinder. Another defect are pine holes, evident in these pictures. Skip weld are a technique to save money, let me say, because in marine environment, the welding should be continuous rather than spot or intermittent. Continuous welding is more expensive than spot welding. However, it extends the life of the coating. If continuous welding is not permitted or not possible due to the thin thickness of metal, use penetrating sealer or caulking in the overlap joint. It is important to use caulking compound that is compatible with the coating system. Epoxy and silicone base caulk are both used with success. In this picture, we see a steel preparation of a small structure. In this case, we are talking about a CPT, control panel test, according to standard NORSOC M5101 revision 6. So the process provide remove weld spatter, clean the round edge, and grind the notch. Yearly corrosion on a sharp edge and spot weld. This is a structure that has been coated, newly applied, and disposed after 2 weeks at the environment weather. You can see that the defects, the rust, the corrosion, start on the edge of the structures and the part of skip weld. Probably the edge are not completely rounded, and a continuous weld, it will be better to avoid this kind of problem. In this picture, we see a good weld stem and a rounded edge. So in this case, we have no trace of corrosion after several times. Surface preparation. The objective of surface preparation is to create proper adhesion or coating over a substrate. Adhesion is the key to coating effectiveness, and it determines whether the coating is merely a thin sheet or material lying on the substrate, or whether it becomes an actual part of the substrate. Adhesion became an even more critical condition for coating applied in corrosive area. Thus, proper surface preparation is vital to the long life and effectiveness of coating applied in corrosive surface. Surface preparation is usually a combination of a number of different treatments. We have a pre-surface preparation or pre-cleaning. Its purpose is to remove any extraneous loose material from the surface on the substrate and any potential contaminant. And the surface preparation, that is the target, is to increase the surface area by increasing the roughness and anchor pattern of the surface. Plan the job and follow the routine is very important. Here you can see the process to a good steel preparation and surface preparation. So remove contaminant, remove all the loose paint and thick layer rust, surface preparation, remove the dust through vacuum cleaning, apply paint. Surface cleanness is important. Surface to be coated requires some pre-cleaning, since the steel that comes from the workshops has surely trace and presence of potential contaminant. Inspecting for contamination, including heavy deposit of grease, soil, dirt, dust, or cement spatter, is an important component of the coating process. Type of contamination could be rust, chloride contamination, most prevalent in marine environment, salt refining industry, and coal mining. We can have also acidic contamination, alkali contamination, and organic contamination. Pre-cleaning methods include solvent wipe with cloth or rag, immersion of the substrate in solvent spray, vapor degreasing, steam cleaning, emulsion cleaning, chemical paint stripping, and alkaline cleaner. I'd like to highlight some of these. Organic solvent, for example, such as kerosene, naphtha, toluol, or mineral spirit, clean the metal by dissolving and diluting the oil and grease contamination on the surface, but they are not able to remove inorganic materials such as chloride, sulfates, and weld flux. Another thing to consider, some organic solvent in use for solvent cleaning may be considered hazardous to health and generally likely to be a fire risk. Some of it are subject to health and safety restriction in many countries. For this reason, detergent biodegradable types are preferred today. In these pictures, you can see the work that is washing the surface to be coated with a detergent. After the washing, it is very important to rinse the surface with fresh water. Oil and grease. Oil present in small quantity on black skin surface may be detected by this test. Pour the solvent across the surface. The solvent should form a continuous flow and not be broken in droplets. Use an ultraviolet light to illuminate the surface to reveal traces of certain hydrocarbon oil, grease, or fingerprints. Ultraviolet light also may reveal other material on the surface, which may or may not be detrimental to the coating. Fresh water is a common, if not powerful, solvent and may effectively clean a surface. Water washing is an ideal process for cleaning paint surface and the correct way of removing dirt and soluble salt. Used to clean the surface after the wash with detergent. Also, it is important to thoroughly rinse surface, particularly when alkaline or acidic material are used as cleaning preparation. This minimizes the amount of soils remaining and remove residual or cleaning material that could adversely impact coating performance. This is an example of fresh water cleaning low pressure used in shipyard. In shipyard, water is used to remove coating, like for example, leached layer or antifouling coating. It's important to understand that water is used not only to pre-clean the surface, but also to remove some particular coating or material that are not tightly loose to the substrate. Contamination. In marine and industrial environment where the air contains particle or chemical salt, it's very known that this salt may deposit on the workpiece. If this occurs after blast cleaning but before coating, it may be necessary to wash and reblast the surface. In extreme case, if a contaminated area after blasting a moisture from the air, change to a dark color and rapidly deteriorate. To remedy the problem of the soluble salt on the surface, further blast cleaning may be effective in some cases, but may be better to wash using high pressure wash equipment. Also in this case, to remove salt, water is necessary. Soluble salt, very important, are not visible and require tests to determine the presence. Here we have some picture that give us some information regarding the quantity of salt and the effect on the coating. We have 4 pictures. These are the first 2. In the first picture, we have poor presence of salt, practically 0 milligram on above square meter, and we don't have any trace of blister. In the second picture, we have 60 milligram, and you start to see some blister. The other 2 pictures are the result is clear. When we have a big amount of salt, we have blister, and blister conduct to corrosion and the consequent detachment of the coating. While the smoke is water soluble and can only remove by water, here in the picture you can see on the left side the welding smoke presence, and in the right side of the pictures the area washed with water. In this case, the smoke flux is completely removed by water. Detergent or solvent are not able to remove the welding smoke properly. If not removed, the smoke can conduct on osmotic blistering. Here the example of osmotic blistering. You can see close to the weld the trace of blistering. While the smoke is water soluble and will create osmotic blistering if not removed. Galvanic difference between steel plate and weld may aggravate the attack. Okay, now we start to see the surface preparation. The surface preparation, we have to consider a lot of things to select the right method. Paint specification, area to be repaired, degree of damage on surface, existing paint system or steel rust gray, tools available, paint system to be applied and require lifetime. Power tool cleaning. Hand tool cleaning is a method to repair steel surface using non-powered hand tool. Hand tool cleaning remove all loose mild scale, rust, paint, and other detrimental foreign material. Other mild scale, rust, and coating can generally be removed by the process in high productive environment. Tools used in hand cleaning include wire brushes, scraper, chisels, knives, chipping hammer. Here we have an example of manual and rotating wire brush. Is a power tool cleaning. Sorry, the rotating wire brush is a power tool cleaning that use power assisted mechanical. Okay, these tools are essentially similar to the tool used for hand and tool cleaning, but with a power source. Manual cleaning is the slower and perhaps less satisfactory method of surface preparation. The process is slow, labor intensive, and costly, with the end result still far from satisfactory. Further, is a heavy work. It's very difficult to keep uniformity of quality of the preparation. And tools have the advantage of being portable and not requiring powers to operate. They are most suitable for use when a small area need to be prepared in the vicinity of the other worker or when access is difficult. Rotary wire brush are available in two general types, straight in line or in vertical right angle. Overworking the surface with a wire brush can be detrimental because excessive varnishing develop a polished surface, which mean a poor anchor profile for the most coating. Another instrument used as power tool cleaning is the needle gun or needle scalers. Consists of several hardened steel rods that vibrate against the surface. Needle scaling is slow and similar to other power tools. It varnishes while producing relative clean surface, but in this case, it produces a surface profile. Needle scalers are effective on welds and corner and irregular surface. Here we have an example, a video that shows us the needle gun working. The needle penetrates the surface, shattering the coating or rust on the substrate. A high surface profile is achieved and generally require high bill coating or light sanding or grinding to even the high uneven profile without polishing the surface. This sanding and grinder and often used to prepare the surface for coating, and the machine powering this tool may be the same as those used for power wire brushing with suitable sanding disc or grinding wheels substituted for the wire brush. Also in this case, the use of the tool, depending on the abrasive glue size, could be critical. This tool is suitable for feathering the edge of intact paint after spot repair. Here are some pictures with polished direction and welds. You can see the area around the welds completely polished. It's very important that you make it before the sandblast because any coating remain attached as adhesion on this kind of surface. When you polish the surface,